Let's go to that first term, which is the name of the game, artificial intelligence. The definition is pretty simple. I think everybody here knows what it is, but it's basically machines simulating human intelligence for tasks like decision-making, learning, problem solving. Now, that's not a bad definition as far as it goes, but the truth is that we are increasingly expect AI to do some other things like collaborate with human beings and actually take action. So there's a lot more talk about AI agents. We'll talk more about that going forward, but this is sort of one of the big buzzwords you'll hear a lot in 2025, as well as robotics. Now, I know some of you are manufacturing, you probably have some robotics within your organization, and the type of robotics that we're generally applying to this are sort of the robotics like you're going to see like in an Amazon warehouse that are doing certain things, more generalized robots that are going to be taking certain human tasks maybe and are more shaped like human beings instead of like some of the robots we're going to see in a manufacturer. So yeah, we'll get into all these things, but that's sort of the basics of that. Generative AI. Wow. So generative AI is just stuff that generates. It generates words, it generates art, it generates video, and it generates language of all types. So it is what it says. It's generative. It creates a lot of new content just by analyzing existing data. They're pre-trained. So if you're looking at something like ChatGPT or Gemini or Anthropic, some of the big names in the field, they're really pre-trained, which just means they spend sometimes months training these models, and then when you interact with them, they generally don't remember anything, and they're not generally being trained as you're using them. Instead, they generate things based on their existing data. The transformer part, the GPT, the transformer part is just a kind of deep learning architecture, and it enables it to understand the context and the relationships and text efficiently. There's a lot more to this. I guess one thing I should mention, because it's going to come up several times, is that GPTs are next token predictors, which just means if they're trying to predict the next word or part of a word in a sentence, and they actually have a kind of algorithm that they're going to use, and you can never be sure exactly what they're going to say next, and which is one of the reasons you can ask like a GPT or another AI a question. You can ask the same question 5 times. You might get slight variations on that answer every time because there's a predictive part of this. It's a randomized generator that's behind the scenes. So it's not just predicting words these days, it's also predicting things like images and things like that. So I think that's probably enough detail on that, but I'm always happy to answer any questions on that kind of thing. So let's go to the next one. Machine learning. I'm not going to dwell a lot on machine learning. They're really AI systems that improve over time by learning from data. If you were using AI a few years ago before ChatGPT hit the market, you're probably using some kind of machine learning based tool. And really what machine learning is good at is analyzing a lot of data, seeing patterns within that data, and then making certain predictions about that data. So it's really good at like if you're using Netflix or something like that, and it's predicting the next kind of movie that you might like to see, and it's giving you suggestions, that's usually going to be a machine learning model in the background that's learning the patterns that you're watching them, applying to larger patterns, and then giving you some prediction. So when you look at the older school HR applications, usually they're based on machine learning of some sort. Neural networks. So we're starting to really get into the name of the game here. Neural networks have been around a long time. They actually were invented back in 1943, I believe, by a neurophysicist and a mathematician. So they kind of just put these ideas together. And then people like Rosenblatt, Dr. Rosenblatt, back in the 1950s, put together something called the perceptron. And the perceptron was something like what you're seeing here in this slide, where you have input, you have some hidden variables, and then you have some output. And it was very interesting at the time, but it didn't work terribly well. And one reason it didn't work terribly well was the compute wasn't high enough. We just didn't have powerful enough computers. But still, most of what we're using today that we're going to be talking about today are based on some kind of neural network. And then deep learning is just a more sophisticated type of neural network. When you're looking at these GPTs, AIs, virtually everything on the market right now is going to be based on deep learning. So deep learning network is just a type of neural network and has lots of hidden layers. Like usually if you have a basic neural net, it just has one hidden layer in the middle. These have many hidden layers, which just means it's going to get very, very complicated. They call these linkages neurons, kind of based loosely on the human brain. But what they really are the strength of mathematical relationships between these different nodes. And so those are the neurons. That's how the machine does its job. So you end up training something, like you put up a number on a screen, and then you're trying to train the model to recognize that as a number one. And it doesn't do it, and then it slowly learns. There's a thing called back propagation, which I won't get into too much, but basically that just means if it's trying to learn something and it hasn't learned something, then on the backside you say, no, that was wrong. Here's something that was more right, and it kind of goes through its cascade again and again until it kind of learns it over time. So they're pretty complicated in practice, but they're not that complicated in terms of what they actually are, which is just relationships between numbers, zeros and ones behind the scenes. And that's how they actually do the prediction. And I think this is probably the last sort of jargon, the NLPs, natural language processing. NLPs are the kind of things that we're using to do translation. So the translation engines are very, very good these days. If you want to translate between English and Chinese, you have some very, very good programs that do this. And these are also based on learning programs, deep learning, and they're really good at things like, we have some benefits like HR resume screening, chatbots for candidate engagement, employee feedback, sentiment analysis. These are all things that are NLP behind the scenes. But we just think of them as AI, and they are various forms of fairly similar types of artificial intelligence.